Hey folks, welcome to another set of 8th grade science video notes. Today we're going to start our third unit, which is all about chemistry. In this lesson we're going to talk about atoms and the difference between elements, compounds, and mixtures. Here's the specific Indiana State Standard that'll be covered in this lesson. Let's get started. Now, this slide should mostly be review for you, but just to make sure you know it, here we go. All matter in the known universe is made up of some combinations of the 118 elements that we know of today. Each element is distinct from every other element and has its own unique chemical and physical properties. In fact, the number of protons in an atom is the big defining characteristic that tells us what element our atom is. Atoms are made up of two locations: the nucleus, which is right in the middle and makes up most of the atom's mass, and the electron cloud, which is outside of the nucleus and makes up most of the atom's volume. There are three subatomic particles, that means smaller than an atom, that exist in an atom: protons, neutrons, and electrons. Protons and neutrons both have a relative mass of 1 AMU, and they both exist in the nucleus. The difference lies in their charge. Protons are +1 and neutrons are neutral or 0. The third subatomic particle is the electron. Electrons are very different, as they're the only subatomic particle that live outside of the nucleus, and they have a relative mass of 0, and they have a charge of -1. Now, when we have one atom, it's pretty easy to tell what it is. We just figure out the number of protons, relate that to the atomic number, then find the atomic number on the periodic table. If we have more than one atom, there are several different ways that our atom could be arranged. If they're connected or chemically bonded together, then we have a molecule. Molecules can either be elements or compounds. A molecule that's an element is made up of two or several elements that are exactly alike. Some examples would be oxygen, which is a molecule made of 2 oxygen atoms, or sulfur, which is a molecule made up of 8 sulfur atoms. As long as each atom that makes up the molecule is the same element, we just call that molecule an element. Now, if our molecule is made up of more than one type of atom, we call that a compound. Water, which is made of 2 hydrogen atoms and an oxygen atom, would be considered a compound. Methane, which is made up of 1 carbon and 4 hydrogen atoms, would also be considered a compound. If we have several atoms or molecules that are just thrown together but aren't chemically bonded together, we just call that a mixture. Lastly, sometimes instead of molecules, we have extended structures. Extended structures are kind of like molecules, but they're made of several smaller units that repeat themselves in the overall structure. For instance, the element carbon could exist as a diamond or as graphite. Both of these structures are just repeating patterns of carbon atoms connected together. Table salt, good old sodium chloride, is another example of an extended structure. There's no distinct molecules in sodium chloride, but there is a 1-to-1 ratio of NAs and CLs. That's why the formula is just NaCl, not Na a billion and Cl a billion. The Na and Cl together are repeating subunits of the whole structure. If all our particles or each chunk of our substance is the same, in other words, if there's only one type of element, molecule, or compound in the whole substance, we'd call that a pure substance. A mixture would be when two different elements that are not combined together with a chemical bond, or a couple of different types of molecules, were just thrown together. Since the composition, how much of each thing it's made of a mixture can change, its properties can change. A pure substance, however, does not have a changing composition. Sodium chloride is always NaCl, methane is always CH4, etc. Because of this, pure substances have predictable properties such as melting points, boiling points, viscosity, density, and so on. All atoms and molecules have some level of attraction to each other, even if those attractions are so small that we usually just ignore them. If the attractions are very weak, then our substance is likely to be a gas, since the particles don't stick together very well. The higher the attraction between the particles, the more likely the substance is to be a solid at room temperature. When we have a solid, heating it up eventually allows us to overcome those forces of attractions that hold the particles together. When this happens, our substance turns to a liquid. Heat it up more and it can turn to a gas. Those different temperatures in which solids turn to liquids or liquids turn to gases are called the melting and boiling points, respectively. Another important property of matter is viscosity. Viscosity is basically a measure of how slowly a substance flows. The higher the forces of attraction between particles, the more the particles stick together and the harder it is to flow. Therefore, more attractions means a higher viscosity. Speaking of attractions, in the bottom left corner of whatever page you're writing on right now, go ahead and write down your favorite vacation spot. This could be a state, a certain beach, some amusement park, whatever. If you do this, you'll get a few extra points in your notebook for actually listening and paying attention to the notes video. Good job, you. At some point, you may be given a list of molecules or compounds to create and draw a model of. This is not always a perfectly easy task, but with this handy-dandy chart, anything is possible. Each atom has its own set of electrons, and the outer layer of those electrons are the ones that participate in chemical bonding. On this chart, you see dots around the symbols for each element. Those dots resemble those outer electrons that will be used for bonding. If you see any dots that are all by their lonesome, that's when you know that element will bond. Each electron wants to be a part of a pair. We can use that knowledge to figure out how our atoms will be arranged in a molecule. For example, ammonia, NH3, is made up of 1 nitrogen and 3 hydrogens. Why is that? Well, ammonia has 2 electrons that are already paired together, but there's 3 of them on it that doesn't have a buddy. And so it takes 3 of these hydrogens, which each have 1 lone electron on them, to buddy up there with the nitrogens. And now all of our electrons are paired up and everybody's happy. As you can see, writing down these symbols and putting them together to pair up electrons is not terribly difficult. The last 2 things for today are to know how to write formulas if you're given a drawing of a molecule, or to draw molecules if you're given the formula. So, if you're given a model of a molecule and you're asked to write the formula, it's very easy. All you have to do is write down the symbols that you have in your molecule, and if there's one in the middle, that's usually the first one we write down. And then count up how many atoms of each one you have. We don't always write ones, so C is just C here for the formula, but there are 2 oxygens, so it's O2. So the whole formula for this molecule is CO2. Chlorine, there's 2 chlorine atoms, so it's just Cl2. These little numbers that are just to the right of the symbol that they go with are called subscripts, and they tell us how many atoms of each element there is. To do the other way around, if you're given a formula and have to draw the molecule, go back to the chart that we had on the previous slide and draw out the symbols for each of the atoms that you have. So for CH4, we have 1 C and 4 H's. So I drew 1 C and 4 H's. And then move them around as you need to pair them up so that there are pairs of electrons together and there's no electrons all by themselves. And then you can replace those shared pair of electrons, or those electrons that are stuck between 2 atoms, with a line, and those lines are called bonds. And that's all you have to do to draw those. For PCl3 is a great example. It already has 2 electrons that are paired up, so we just leave those for the whole process. We don't change those at all. But phosphorus has 3 lone ones, and chlorine has 7 electrons, but only 1 of them is unpaired. So they pair up like this, and then there's your molecule for PCl3. Well, that's all for today, folks. I hope you learned at least a little bit about elements, compounds, and mixtures, and are now ready to tackle the practice for this lesson. As always, if you have any questions, ask.